Live streaming is gaining popularity in many domains, including gaming, creative live streaming, and knowledge sharing. The viewer interaction has been one integral part of it, and it had been majorly done by chat interactions. Recent systems have tried to expand viewer interactions to other modalities, and among them, visual inputs have a lot of potentials to increase viewers' expressiveness and facilitate communications. However, one limitation of current systems is that it is hard to handle a lot of visual inputs from viewers while not losing expressiveness. Existing systems either limit expressiveness in viewer inputs to simple marking, are specialized in a limited context, or show only selected inputs. In this work, we introduce Visual Input Management Framework and VisPol, a system built out of the framework. Our framework and VisPol help streamers to understand many visual inputs from viewers, without losing the expressiveness and versatility of visual viewer interactions. First, let us show some of the use cases. Let's assume that a teacher wants answers to the question in remote lecturing, how would electrolysis work on water, and where oxygen and hydrogen would be generated. With VisPol, the streamer lets viewers answer this question with visual inputs, in this case, with 2 hydrogen molecules and 1 oxygen molecule. After collecting inputs from viewers, the streamer can visualize them, with each row indicating each group of answers, with the size indicating the number of people who answered so. The streamer can create this interaction before the lecture, and use the stored interaction template during the lecture. Or, they can also try to improvise this interaction during the lecture, starting from one of the preset provided by VisPol. Another example is physics, where the streamer asks viewers to place an arrow indicating force on the real video. Viewer inputs would be aggregated and visualized in a sensible way, with the width of the arrow indicating the number of people. Our framework, and VisPol, enable these by allowing streamers to specify, aggregate, and visualize viewer visual inputs. These viewer interactions can be configured during the streaming, or prepared beforehand and stored in the configuration library. For specifying what visual inputs viewers can make, the streamer set visual attributes of the visual inputs. The streamer can first place a region where viewers can make or manipulate visual inputs. Then, streamers can decide which shapes can be added by viewers, which types of stickers or text boxes. Also, the streamer can decide not to enable a certain shape of objects. After that, the streamer can configure other visual attributes, like size, rotation, color, and the number of objects allowed in the area. For size allowed for visual objects, the streamer can directly click on the area to specify it. For rotation, the specification can be done by clicking on the wheel, but as if rotation is not an important aspect in the viewer inputs, the streamer can set it to the default value by disabling it. The interaction of specifying the color and the number of objects is similar to that of rotation. The streamer also can give objects to the viewers, if they want them to use specific objects. After all visual input specification, the streamer can allow viewers to make visual input. After the collection of viewer visual inputs, the streamer can aggregate collected visual inputs and visualize them. First, the streamer can create an aggregation by clicking on the video screen. The system asks the streamer whether to aggregate all objects or only given objects. After the streamer chooses one of 2 options, the streamer can select which visual attributes variables to consider in aggregation. It is to only consider important variables among all possible visual variables. Here, the streamer is only considering X positions of given objects. After that, with a slider, the streamer also can choose how many groups will be created as the result of the aggregation. If the streamer hit Next button, VisPol will conduct the aggregation, and the streamer can specify visualization of it. The visualization is done with axes and glyphs, where glyphs are placed along the axis. The streamer first need to configure which aggregated data attributes, or variables resulting from the aggregation, will decide the position of glyphs. It can be aggregated visual attributes, or count of viewer inputs in each group, or similarity metric that indicates how groups are similar to each other. After choosing the aggregated attribute, the streamer can place the axis on the video screen by moving handles on each end of it. The streamer can do more complex axis layouts by adding a new axis, or combining 2 axes together. The streamer also can change the visual of glyphs by matching its visual attributes to one of the aggregated data attributes. Here, the glyph's shape is matched to the shape of the aggregated visual inputs, and the size is matched to the count of viewer inputs in each group. With these interactions, the streamer can configure the visualization as they want. The streamer can present configured visualizations to viewers. As doing all the configuration during the streaming can be challenging, We also allow streamers to save these configurations and load them when they want. We conducted 3 user studies in remote lecturing and creative live streaming. In a Korean remote lecture, the streamer used VisPol to collect viewers' annotation on clauses in the sentence, and visualize them with height of the box indicating number of people who answered so. In computer science remote lecture, the streamer used VisPol to collect the order of numbers after some iterations of the bubble sort algorithm. The streamer visualized each answer in each row, with the size of objects indicating the number of people. We also found that it can facilitate viewer engagement while allowing streamers to understand viewer visual inputs.